this example, we are going to look at the rotating bending of a shaft. The shaft has an internal bore hole and a cross hole. The finite element net of the model is made up of hexaedral elements. In this finite element calculation, we do not want to rotate the shaft. Rather, the load is turning in angular increments, and that means the same. Now we can see the deformation and stresses for the load angle 0 degree. Now the load angle 90 degree is shown, and with its deformations and stresses. Then the shaft is shown again for load angles 180 and 270 degree. The size of the load amounts to a standard 100 Newton is for all four angles the same. The finite element results are now exported. To do this, we use the WinLife FEMAP interface. The complete stress tensor is needed for the fatigue life calculation, which is why we select a multi-axial export. An output file is defined for the export. All four load cases which are selected here are exported. In the next step, we shift to WinLife and we create a project called Rotating Bending. The rotating bending is shown by a multi-axial load with the four load cases previously exported. A SN curve according to the FKM guidelines shall be loaded for the material 42 chrome molybdenum 4 and shall be modified. Here we select from the database the material data. The surface roughness is adjusted as well as the effective diameter of the shaft. Now the SN curve is shown which we created. In the next step, we have to create the load. To do this, we use a Sinus generator in order to create a large number of values. A revolving load of 150 Newton is active here. The selected angle size is 90 degrees. For 1000 rotations of the shaft, the number of periods should be set to a value of 4000 because of each rotation of the shaft there are 4 splayed windows or periods. Since there are 2 values for each period, we have a total of 8000 values. These values are divided up according to 4 angle increments. You should select the setting value per splayed window. The file created is now entered into the loading menu. The diagram shows the load history corresponding to each of the angle positions. In the next step, the finite element data are read in. Be careful to keep the 4 load cases in the correct order. Select the parameters for the calculation. Generally, the standard settings are taken over. The mean stress influence is taken into account with the amplitude transformation. We want to take into consideration any possible residual. We select damage accumulation, elementary form, and then we start the calculation. We see the damage sum. It is 3.2 with a power of -10. This is the equivalent stress curve for the node number 7420 known, the node with the highest damage sum. Now we shift it again to FEMAP. The neutral file, which was created during the fatigue life calculation, is now read into FEMAP. The damage sums for the nodes are shown. The cross hole is subjected to the greatest stress. Here we see the results of the fatigue life calculation. In a further test, we want to select a more realistic load for the rotating bending. For this, a measurement file is divided into the relative splayed windows using the command load sharing. The file created is transferred in the load menu in the same way as constant load was in the previous case. The calculation parameters are then taken over in the calculation where we started. The maximum of damage is 2.98 exponent -6. The results are then taken from Winloaf and shown in FEMAP. First of all, the distribution of the damage is shown. The greatest damage can be seen in the cross hole. Now we show the degree of the utilization. We can see that 7.9% of the endurance limit is used. This is the end of this example. Thank you for your attention.